All right. Hopefully everything goes. We're loading up. Howdy everyone, it is Harley from the Family and welcome back to the channel. And I have a little intro jingle for y'all. Hope y'all are doing well. Let's go ahead and actually let me turn this a little bit. Oh yeah, you can see my mess out of the way, huh? Okay. So I wonder if I turn my desk on. Nah, we won't do that right now. But let's go ahead and log in for the night. Oh, wrong password. Hope everyone is doing alright today. Alright. Alright. Stream's current bitrate is super low. No, it's not. I see nothing wrong with my stream. Liar? Okay, maybe so. Alright, so let's go ahead and get our music going. Gotta love that music, baby. Okay, let's pause our actual view of the live stream and let's get into some learning spirit here. Alright, we're gonna go ahead and log on to little old Google. Those of you just tuning in or becoming part of the community here at the Family, I want to say thank you guys for being a part of me on this journey. And I want to say that every single one of you is appreciated in a million ways. Sicky keys? I don't want sicky keys. No, turn that off. No. Okay. Oh, it logged me out. Okay, so let's continue where we were. I feel like I'm very high up right now. Cool. Okay, and then we're gonna open up our repo and JS example sheet. But yeah, everything has been going swell in the Family man plays place. Just trying to power through life as all people do. Okay, so I think what we needed to do the last time, if I remember correctly. Okay, what did we do? Set another variable to... Oh, okay, we were going through, how does the percent operator... Oh yeah, let's download the update. Oh, I have to do it through, yeah, we won't mess with that just yet. We'll do that later. So how does the percent operator work? Explain the difference between equal equals and equal equal equal. Okay, so that was probably some of the resources that we needed to go through. So this lesson followed by this one are good introduction to what you can accomplish with numbers in JavaScript. So let's go ahead and do that. Okay, so we got addition operator, subtraction operator, multiplication operator, Exponent operator, so the double asterisk, the division symbol, modulus, so remainder, increment, so plus plus, and decrement. So let's kind of go through these, huh? So arithmetic operations, typical arithmetic operations. Oh, we can actually do this like that. Or, there we go. Okay, put this on this side. And this one. There we go. Okay, and then what we're going to do is inspect, have the console open, and we're going to follow these examples. So like, let x equal 100 plus 50, and we kind of did these kind of examples before, but if we let, what is x, right? X is 150, and then we can also add, we can also change things, right? So let's let x equal a plus b. Cut is not defined. Oh yeah. So a or b is not defined, so then we'll do let x equal 100 plus 50 times a. So what is x? X is still defined as 150. So a would be 1. A okay. So this is expressions, adding variables. A typical arithmetic operation operates on two numbers. Two numbers can be literals, variables, or expressions. So here we go. Operators and operands. The numbers in arithmetic operation are called operands. Okay? The operation to be performed between the two operands are defined by an operator. Ooh, I forgot about our notes. So this is going to be let's rename this one to JavaScript Fundamentals. Lesson 1, right? Okay, and we'll put operand is are the numbers, and operator defines the action the operator performs a certain action based on which operator type. But usually between two or more operands. Example 5 plus 4, 23. Yeah. The numbers are... Oh, hey Gunnar. Shout out to Gunnar. How you doing, you handsome devil? The numbers are the operands, and the addition symbol is the operator. Yeah, shout out to Gunnar, #1 fan right there, my boy. Hell yeah. Going through a night of coding for a little bit, at least for an hour or two. I gotta keep going through this stuff, man. I hope you're doing alright, Gunnar. Hope life is treating you well recently. Things are gonna start looking up. Change is coming. I don't know what kind of change it is, good or bad, but I know it's coming. So addition operator, we can add variables, we can subtract between numbers and variables, and expressions. And expressions would be like how for that example was 100 plus 50 and then times a, right? And I'll put a little arrow. Example of an expression operation. And the expression is the two numbers in parentheses. Dividing, remainder. Okay, so remainder. This is going to be a different one. So let's try that. So let x equal 5. Let y equal 2. And then we're going to do let z equal x percent, or so x remainder y, and then z would be 1. But why is that? So that would be 5. Oh, gotcha. Okay, because 2 can go into 5 2 times, but there's still a remainder of 1. I know maths. Okay, so that's cool. Okay, now I know what the remainder thing is. Incrementing. So I believe that would be an increment of 1. Increment operator. Okay, let's try that. Let's do x plus plus. Oh. So, sorry, x plus plus. Gotcha. And then let z equal x, z 7, z. Okay. Oh, it already went up. Okay, but maybe I should be doing it in here, right? Okay, so let's do that. I was just kind of doing like this so we can kind of see both sides, because it's a lot of stuff to go through. But yeah, we can do that. Okay. And then decrementing would go down by 1. Exponent would be like let x equal 5, let z equal x to the second power, right? And 5 squared is 25. So when we well, we don't even have to do that. We could just go like this and then call it in here. So let's refresh that and let's do z 25. So there we go. Our answer would be 25. Oh, hopefully you guys can hear me. I know I gotta be talking a little bit louder. My mic does not like to be nice with me sometimes. I might actually need to turn up my microphone a little bit higher. I just don't want it to get pick up too much, because my My AC unit gets pretty loud. I'm actually gonna turn that off real quick, as I am in a garage room. So anyway, so there's exponents, and what is math.pow? X star star y produces the same result as math.pow. Okay. So if we go let z equal math.pow x2. Oh, so that would be the same thing. Let's remove, oh sorry. Oh, oops. There we go. Okay, and now let's go in here and do a z again. Boom, gives us 25. So math.pow is like another little function that we can use. Operator precedence. Operator precedence describes the order in which the operations are performed in an arithmetic expression. That should be, if you don't know maths too well, I would recommend going through some Khan Academy and learning about operator precedence. Even here, there's different operations. Oh, and there's even like oh, I gotta find that resource that I have, but there's even like a resource that tells you which operators go in what precedence as well. So there's a lot of things. So like multiplication and division have a higher precedence than addition and subtraction. So yeah, just like PIMDAS in school, right? So you can have, like in this example, we have let x equal 100 plus 50 times 3, right? So in order of operations, it's going to go 50 times 3 first, and then add the 100 to it. And just to show you, we can go into our example page, refresh it, and just hit X, and it's going to be 250. So 3 times 50 is 150, plus 100 is 250. Pretty cool. And then oh yeah, and then like in this example, like if there was 2 division things in here, it would go in order from left to right, because these are within the same operator precedence. So first we would divide 100 by 50, which would give us 2, and then times 3, which would equal 6. So just to go test out our theory, let's go ahead and go into here and just type in X. Oh, I forgot to refresh the page. X, boom, 6 is our answer. So that would be 2 times 3. And then let's see, and just to showcase another side by side, which would be the addition and subtraction. So that'll be 150 minus 3, which would be 147. So refresh the page, refresh the page, refresh the page. What? No, refresh the page. Refresh. Whoa. Oh, it's because I still have that in there. There we go, 147. Okay. So, what else have we got in here? I think that's, oh, here's the expression precedence. So this is going to be a very useful page. So this is going to be a things to look at later type of thing. And we might need to rename this one to JavaScript stuff. Sir, I have some questions related to you. Please answer. 1, which country do you live? And 2, which company are you employed? I'm currently not well, I am employed. I work at a retail. I work for, well, don't laugh. But I work for Dollar General. I used to be an electrician for a while. I was doing apprentice electrician work for a good while. And then before that, I was a corrections officer. But I live in the U.S., to answer the first question, and then currently I'm employed with Dollar General. But I'm trying to get a tech job right now at the local school here that in the town I live in, because I think that would be a very great start off to my career, because I know a lot of stuff. like about, you know, setting up software and hardware and wiring cables and all that type of thing, because I've done the wiring stuff in the electrical field. But I hope to one day soon be hired. I would love to be hired in a tech company or something, which is why I'm going through this program. Oh yeah. I know I go on for a while too. I don't mean to overtalk. It just happens. Okay, so yeah, this is important. And then test yourself. Divide 10 by 2. Oh, easy. Some answer. Show answer. Oh, these are just... Gotcha. I don't need that right now. Oh, but that's cool. These little challenges are here. Array methods and stuff. This might be very cool to come back to later as well. JavaScript stuff. Okay, so let's go ahead and exit out of that. So we read that one. And let's go through this one. Hopefully this one's going to give us some more information on numbers here. Okay, so this is JavaScript numbers. Let x equal 3.14, a number with decimals, and let y equal 3, a number without decimals. Okay, so you can do decimals, and you can do exponents, or like, oh, I forgot what this is called. Gosh darn it. But that would technically be like, okay, see how there's 5 zeros here? It's like to the 10th power, but it's like 10 to the 5. Like, so this would be like 123 times 10 to the 5th power. That's pretty much what that is right there. And just to show you, so let's do let x equal, so we'll do 123 times math.pow, and we'll do 10 to the 5th. Okay, and we should come up with the same result. So let's go ahead and test it out, right? Oh, I didn't want to exit out of that. I did, didn't I? Okay, so let's go into the console real quick, and just to see what x gives us. Oh, and there we go. It gives us, let's see if I can zoom in. Come on, zoom. Oh, it doesn't zoom in the console? That sucks. Okay, but still we have 1, 2, 3, 4, 5 zeros. So that's the same thing as the 1, 2, 3, E5. I just thought that was a cool little fun fact thing. And then this is 123 times 10 to the negative 5th power. So then we go back 5 decimal places. So instead of going 5 decimal places forward, we go 5 decimal places backwards. So we go 123, 1, 2, 3, 4, 5. So 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5. Anyway, JavaScript numbers are always 64-bit floating point. Unlike many other programming languages, JavaScript does not define different types of numbers like integers, short, long, floating point, etc. JavaScript numbers are always stored as double precision floating point numbers, following the international IEEE 754 standard. This format stores numbers in 64 bits, where the number, the fraction, is stored in bits of 0 to 51, the exponent in bits 52 to 62, and the sign in bit 63. So there's different bits. Okay, so 52, fraction minus exponent 11 bits, and sign 1 bit. Integer numbers without a period. I'm trying to, I need to look up exactly what this is. So let's go here and let's type in Oh no! Oh look, y'all can finally see the kitty. Woo! Look at my baby. She's a very good cat as well. Say hi to the camera, Tina. She can be. Oh, there you go. She can be a little camera shy. Okay, so what was I looking up again? Gosh dang it! Stay still. Okay. Oh my goodness. She wants cuddles. Okay, so we're gonna look up what JavaScript numbers 64-bit. JavaScript numbers 64-bit floating point video. Because I really want to know what this means exactly.
Science.
Hello everyone. Today we are going to discuss about 64-bit floating point representation of number in IEEE 754 standard. We have discussed about number data type in
Okay,
our
I'm gonna
previous
save
two
this to my
sessions,
watch
and
later.
in those sessions I have mentioned about this representation few times.
Okay.
So
So we'll go over that one later just to kind of understand what they're talking about. Integer precision. So this number will be that number. This number will be that number. Okay, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, there's 16 digits. And what did it say? Okay. So it's more... Keep going. Thank you. Thank you, Kenny. Appreciate it, brother. I'm still learning, man. I'm still learning. So floating points. So the maximum number of decimals is 17. To solve the problem above, it helps to multiply and divide. So floating point arithmetic is not always 100% accurate. So 0.2 plus 0.1. Let's try that. Oh, we don't need to exit out of... Oh, sorry, Tina. Sorry. Okay, now she's salty because I didn't let her stay. Okay, so 0.2 plus 0.1, which should be 0.3, right? So let's go see. Refresh, which is 0.3 all the way to 0.04. Okay, to solve the problem above, it helps to multiply and divide. So we can do 0.2, and in an expression, so 0.2 times 10 plus 0.1 times 10, and then divided by 10. If we go here, refresh it, and so now it gets 0.3. Okay, so we would have to, like, to make decimals, we'd have to do some extra steps. But why? Okay. Let's just keep going through it. If you add two strings, the results will be concatenation. Okay, so we know about concatenation. We don't have to worry about concatenation, because we know what concatenation is, baby. Okay. This would, like, this example here would add the x and the y, which would be 30, and then there would be a number 30 at the end of that. And so it'll just be side by side, pretty much. And then x is a number, y is a string. JavaScript strings have a numeric content. X is number, Y is a string. JavaScript will try to convert strings to numbers in all numeric operations. So let's try that. Let's do X equals 100. Let Y equal 10. And then let Z equal X divided by Y. Okay, and then console.log Z 10. Cool. Okay, so you can turn the string into numbers, but when you concatenate, it keeps the number and the string and just sets them side by side. It's as if the number is part of the string. Okay, so you can subtract, multiply, and divide, but you cannot add a string. You can subtract, multiply, and divide a string of numbers, string example 10 plus 100. Sorry, we just said we can't do we meant to say multiply, but you cannot add the two together. And let's find out why. Let's try it. So there we go. It concatenates it again. So it pretty much just keeps it as a string and puts it the 110 as string format. Like even if I were to like add another addition here and just put a space, then I mean, because it's still a string when you add it together. See? Put it back to division. Pretty cool. Alright, let's put that one to sleep real quick and make some space. Okay. So the addition will not work. Not a number. NaN is a JavaScript reserved word indicating that a number is not a legal number. Trying to do arithmetic with a non-numeric string will result in a in NaN, not a number. Example. So we'll do this is going to be for NaN, not a number, and we'll do let X equal 100 divided by a string of apple. And when we go to log it X NaN. There we go. That's all we needed to know. Okay. However, if the string contains a numeric value, the result will be a number. You can use the global JavaScript function isNaN to find out if a value is not a number. So if we do that and isNaN X isNaN X and let's see what kind of error this is supposed to give us. So let x document get element by demo. So we're gonna call into there and place our text into there, and then is it not a number, and it's set to true. I wonder if I did this. Oops. Ah, that would work. That would work. That is so cool. Okay. I just wanted to try it out. I thought that was pretty neat. Okay. Watch out for NaN. If you use NaN in a mathematical operation, the result would be NaN. Or the result might be a concatenation like NaN5. NaN is a type of is a number. Oh, so NaN is a number. Type of NaN returns number. Cool. So the type of not a number is a number. So if we wanted to, we could put that's a number, that's a string. Okay. So these are going to be like useful things for everyone to kind of know when it comes down later, like type of situation, because it's going to be crucial to know when you're going to need a string or when you're going to need a number. Infinity or negative infinity is the value JavaScript will return if you calculate a number outside the largest possible number. Let my number equal to, execute until infinity. While my number, was it this one? I think, hold on. I wanted to see, here we go. So we have equal. So this is checking to see if that is equal. This is making it that it's strictly that number. Oh, sorry, Tina. Okay, and then unequal. Okay. So what this is saying, while my number is not equal to infinity, my number equals my number times my number. So that is gonna. Ooh, excuse me. I feel like an old man. Okay, so let my number equal 2 and execute until infinity. So while my number does not equal infinity, console.log my number equals my number times my number. Okay, let's see how this works. Okay, so I think that's how that's supposed to go. I think. But that's cool. So it just infinitely just keeps multiplying itself, the number by its number. So 2 times 2 is 4. 4 times 4 is 16. 16 times 16 is 256, and then 256 times 2. So it just keeps exponentially growing, which is pretty cool. Division by 0 also generates infinity. Infinity. Sorry, this is going to be infinity example. And then we'll do that and that. And then we're going to do an example for division. So 2 divided by 0. Let y equal -2 divided by 0. There we go. So let's try it. Oh, we can do so this one would be infinity and that one would be negative infinity. And if you guys are paying attention like to what I'm doing as far as like console logging it so that y'all can get the same results, and if y'all are on the same section in the Odin project, if you look here, I have my script in my head tag and I also have a defer to it, so that way it loads simultaneously with the body of the HTML document. So they'll both load simultaneously with each other when they load up on the website. So that might be something useful that we do later on when we like make a bigger project or something. We can defer the the script. But yeah, and then when we console.log stuff, you can log multiple things. I'm sure you've seen this already. But I like working inside of the sheet, even though inside of the fundamentals it said to be working inside of the Google console, the developer tools. I prefer to work inside of a document, JavaScript document. Okay, so we did an example of infinity. We can close that. But yeah, that's going to be important later, the not equal sign and all that kind of stuff. And then hexadecimal, so we can make values have hexadecimal values to them. Okay, so let's try it. Let x equal 0xff, and we're going to console log x, and let's see what happens. 255. I'm your number one fan, Daddy. Ooh, thank you, Boo Boo Bear. Thank you. And hexadecimal is base 16, decimal is base 10, octal is base 8, and binary is 2. By default, JavaScript displays numbers as base 10 decimals, but you can use the toString method to output numbers like base 2 or base 30 to base 36. Hexadecimal is base 16, decimal is base 10, octal is base 8. So my number is a string. Let's test that out. So this is hexadecimal, and we're going to highlight this, and then we're going to try let my number equal 32, and then oh, I didn't even spell that right. My number dot to string, and then 32, and then we can just copy all these down. See, I don't know why it does that when I just want to copy down. Hold on, let me do this, and then let me do this. There we go. And then I guess not. I really wanted to move it down. I mean, be able to copy it down, because I was able to do it before. I just don't know how I did it anymore. Anyway, we'll just paste it. So 16, 12, 10, 8, 2. Okay. And let's do this. I'm just having too much fun with this right now. Okay. Fix that. Okay, so now let's try that. There we go. So now we converted them into their different formats there. So this is so we got, sorry, base 32, base 16, base 12, base 10, base 8, and base 2. Pretty cool. Now I forgot how to do binary. I had to learn binary when I was in the electrical field. Don't know why, but I had to take a class on it. Well, it was like a whole math class that we needed. It's pretty cool. Okay, so let's see, what else do we have? Okay, JavaScript numbers as objects. But numbers can also be defined as objects with the keyword new. The new keyword complicates the code and slows down execution speed. Number of objects can produce unexpected results. Well, let's try it. Why not? Oh, wrong button. There we go. Okay, so let's do let x equal 123, let y equal new number. And see what happens when y goes off. So it creates it into an object, which is this. And objects can have different, all sorts of values in it, which we will learn later. And then when using the equal operator, x and y are equal. Okay, so I'm not even seeing. What did it want us to do here? Oh, okay. It wanted to add it. Gotcha. Okay, so let's go back here. Let's do this. So we'll do let x equal 300, let y equal 300. console.log, because I think that would give us a boolean. It'll give us, yeah, true or false. So we can say, is x equal to y? Question mark, and then we go in here. It is true. But if we change it to 250 and went back and refreshed it, it's false. So what about strictly, right? So let's go back, let's do 300. True. True. False. Yeah, so I don't know why I said true. Go back. This Indian article covers the same info from a slightly different point of view while also teaching you how to apply some basic math in JavaScript. What is wrong with you? Okay, come say hi. Is it getting hot in here? It feels like it's getting hot. Oh yeah. Okay, hold on. She's the best cat ever. And don't worry, I pat her butt all the time. I don't hurt her. Don't think that I hurt my cat, please. Because I don't. I love my cat dearly. She is a family member in this house. She is... I don't know how to put it. It's like a child, you know. Some people have, you know, they think of their pets as like kids and stuff. I don't fully think of it as a kid. Obviously, it's a pet to me. It's an animal, you know. They have their own mind and ways of living their life. I can't control because obviously they're animals and they have their own things. But I don't think of her like as just nothing though. I would never hurt her. She's a good kitty cat. All she does is love on people. Right, Tina? Such a good girl. You a good girl? You like booty pets? Good, Tina. Okay. No, I'm sorry. I'm studying right now. Okay, so far so good. So there's MDN, read through and code along with this article about operators from JavaScript. Don't forget to do the task at the bottom of the page. It will give you a pretty good idea of what you can accomplish with numbers, among other things in JavaScript. So let's go ahead and do this. Excuse me. The basic operator is math. We know many operators from school. That was weird. We know many operators from school. There are things like addition, multiplication, subtraction, and so on. In this chapter, we will start with simple operators and then concatenate on JavaScript specific aspects not covered by school arithmetic. Terms, unary, binary, operand. Before we move on, let's grasp some of the common terminology. An operand is what operators are applied to. For instance, in the multiplication of 5 times 2, there are 2 operands. The left operand is 5, the right operand is 2. Sometimes people call these arguments instead of operands. An operator is unary if it has a single operand. For example, the unary negation minus reverses the sign of a number. So let x equal 1, x equals -1, alert x, and then -1 unary negation was applied. Okay, so that makes sense. So it's pretty much like saying x times -1. It's basic algebra right there. An operator is binary if it has 2 operands. So let x equal 1, y equal 3, alert y minus x. So that's 2 operands. So unary, binary, and what was the other one? Unary, binary, and the following math operations are supported. So we got addition, subtraction, multiplication, division, remainder, and exponentation. The first 4 are straightforward, while percent and double asterisk need a few words about them. Remainder. The remainder is an operator. The remainder operator, despite its appearance, is not related to percents. The result of A remainder B is a remainder of the integer division of A by B. For instance, alert 5 remainder 2. 5. What? Pretty much 5 divided by 2 is the remainder. That's pretty much what it's saying. Alert 5 divided by 2, what is remainder? Alert 8 divided by 3, what is remainder? So when we divide by 3, we can go in there twice, so 6, and then 8 minus 6 is 2, so 2 is a remainder left. Because remember, when we get a whole number, so like 4 divided by 2, our remainder will be 0 because we don't have any remaining integers left. Exponentation, so we know about that. And then we can even use the power of half as well. Okay. Power of half is the same as a... Excuse me, I'm sorry. String concatenation with binary plus. Note that if any operand is a string, the other will be converted to string 2. Oh, it was giving us the answer over here. Where's it at? Did I go too far? Yeah, right here. So it would give us 2, so that'd be the square root, and this is the cube root. Okay. Because 2 times 2 times 2 is 8. So 2 times 2 is 4, 4 times 2 is 8. And then square root of 4 is 2. Jeez Louise, I'm tired. It just hit me out of nowhere. I think I'm going to call it a night. I'm off tomorrow, so I can actually stream tomorrow. Hell yeah, sweet. No work, I can stream. But I just want to say thank you everyone for tuning in. Thank you for the likes. Thank you for subscribing to the channel. I appreciate every single one of you. Thank you for being here with me on this journey to becoming a full stack web developer. Learning JavaScript is just the beginning. It's going to be so fun. We're going to get through all of this stuff, go through everything, and learn what it takes to become a full stack developer. And I think we're doing fairly well, because if we look at this, we are here. Let's take a look at what the fundamentals part 2 is. So this is name the 8 data types, understand the difference between single, double, and backtick quotes, embed a variable expression in a string, understand. And then depending on what kind of work you're doing, you might end up working more with pieces of text rather than numbers. A string is simply a piece of text and is fundamental building block of the language. MDN, conditionals, what else? Assignment. Additional resources, expressions tutorial. Okay, so we got some stuff to look forward to after we finish reading some more stuff tomorrow. But I know, Tina, I know. But I want to say again, please understand that I'm very grateful for everyone that comes through. This is like, anytime, I mean, I know no one's going to get this far in the stream, but anytime anyone watches or cares to want to learn something. And I know I'm just reading over information and just kind of going over it, but this is, it can help someone in need that doesn't fully understand something, and maybe I might say something that just clicks with somebody and they just completely understand it. So those of you that keep liking, that keep subscribing, keep sharing, and helping this channel boost and grow, I just want to say I'm deeply grateful and thankful for all of your support. It means a whole lot to me, because this is what I want to do. This is my dream. This is my passion. I want to become a developer, and it only sucks when I work a lot, and of course I got a family that I have to take care of, and trying to fit time to do this at the same time that I have everything else going on. It's very difficult. It's like sometimes feels impossible, but I know that's not true. It is possible. So, and me being able to continue live streaming and continue getting further and continue learning, that just proves that it's not impossible. And I want this to be kind of like a lesson to those that also have lives. Everyone has their own life that they're living, but despite all of that, you can continue to become better, smarter, and become what you want to become, because this is the only life we got, and we got to make the most of it. So I'm following my dreams and my passion, and those of you that tag along and are doing the same, keep on pushing. We're gonna get there together. So don't feel discouraged. Don't feel like you're not making it. Don't feel like you're not understanding the material or whatever you're doing in your life. Honestly, even if it's not programming, just know that things are going to be okay, and it's going to get better, and everything takes time. Every day you live and you push forward to your goal, your dream that you have, is one step closer to that dream or your goal. So just think of it that way. So on that note, you'll have a good night, morning, wherever you are. It's 5 o'clock somewhere, and remember that actually, hold on, let me fix that. We are one. We are all one. That is my message to the world. Anyway, talk to you all later. Bye. Bye. I'm just kidding. Alright, bye.